Now close your eyes, take a comfortable breath, and drift with me slowly into the paradoxes of an infinite universe. Imagine, if you can, a universe that never ends. Not a universe that is simply very large, so large that you could never hope to traverse it in a lifetime or even in the lifetime of civilizations. No, imagine a universe that is actually infinite, stretching on forever in every direction, containing endless space, endless galaxies, endless stars, endless possibilities. This is not science fiction or philosophical fantasy. This is a real possibility suggested by our best observations and theories of cosmology. The universe we inhabit might truly be infinite, and if it is, then everything becomes strange in ways that challenge our deepest intuitions about reality, identity, possibility, and meaning. The idea of an infinite universe is both ancient and modern. Ancient philosophers speculated about infinite worlds and boundless space, though their notions of infinity were often vague and metaphorical. The modern scientific concept of an infinite universe emerges from general relativity and observational cosmology. When we measure the geometry of space by observing the cosmic microwave background and the large-scale distribution of galaxies, we find that space appears to be flat, or very nearly flat. In the framework of general relativity, a flat universe that emerged from a Big Bang and has been expanding ever since is most naturally interpreted as infinite in spatial extent. This does not mean the universe was infinite at the moment of the Big Bang. The Big Bang was not an explosion in space, but an expansion of space itself, and in the first moments, all the space that would eventually become our observable universe was compressed into an incredibly small, hot, dense state. But if space is infinite now, it was also infinite then, just with all distances compressed. An infinite universe has always been infinite, even when it was unimaginably dense and hot. This is a difficult concept to grasp, because we tend to think of infinity as something that grows or extends, but mathematical infinity is absolute. Something is either finite or infinite, with no intermediate states or transitions. The evidence for a flat and therefore possibly infinite universe comes primarily from measurements of the cosmic microwave background radiation. This ancient light, released when the universe was only a few 100,000 years old, carries information about the geometry of space encoded in the patterns of tiny temperature fluctuations across the sky. These fluctuations tell us how curved or flat space is. Current measurements indicate that if space has any curvature at all, it is so slight that the universe must be at least hundreds of times larger than the observable region, and quite possibly infinite. But what does it really mean for the universe to be infinite? It means there is no edge to space, no boundary beyond which nothing exists. If you could somehow travel in a straight line forever, you would never reach an end. You would pass galaxy after galaxy, supercluster after supercluster, stretching on without limit. Every direction you look extends to infinity. There is no center to an infinite universe, or rather every point is equally the center, because from any point, infinity extends equally in all directions. This infinite expanse has profound and strange implications. If the universe is infinite and matter is distributed throughout it with some degree of uniformity, then everything that can happen does happen somewhere. This is not a metaphysical claim, but a mathematical consequence of infinity combined with finite possibilities. Consider that there are only so many ways atoms can be arranged within a given volume of space. The number is enormous but finite. If space extends infinitely and contains matter distributed with some regularity, then every possible arrangement of atoms will occur somewhere, and indeed will occur infinitely many times. What this means is astonishing and deeply paradoxical. Somewhere in an infinite universe there is a region of space identical to your immediate surroundings. Not similar, but identical down to every atom, every photon, every quantum state. In that region there is someone identical to you, reading these exact words, having these exact thoughts. This is not your twin or your copy in some metaphorical sense. This is you, or rather a physical system indistinguishable from you in every measurable way, existing in a distant part of the infinite cosmos. And not just one such copy. Infinity is strange in that once something occurs once, it must occur infinitely many times. There are infinite versions of you scattered throughout the infinite universe, some living lives identical to yours in every detail, others diverging in small or large ways. There are versions of you who made different choices at key moments, versions who chose different careers, different partners, different paths, versions who live in civilizations slightly or radically different from ours. Every possibility that can be realized is realized infinite times over in an infinite universe. This leads to what philosophers call the problem of personal identity in an infinite universe. What does it mean to be you if there are infinite copies of you? Which one is the real you? The natural answer is that they are all equally real, all equally you in some sense. But this seems to violate our intuition that each person is unique, that there is one definite individual corresponding to your sense of self. In an infinite universe, uniqueness becomes problematic. You are not one individual, but an infinite ensemble of individuals, all sharing your memories and identity up to this moment, all experiencing themselves as singular and unique. Some philosophers argue that this shows personal identity is more about continuity and perspective than about uniqueness. You are you not because you are unique in the universe, but because you are continuous with your past self and because you experience the world from your particular perspective. The existence of infinite copies does not change your continuity or your perspective. From your point of view, you are still a single individual with a single life. The copies exist, but they are beyond your causal reach, unable to interact with you or affect your experience. In a sense, they might as well not exist as far as your life is concerned. But this does not entirely resolve the paradox. If there are infinite copies of you, and if all of them are equally real, then in what sense are you, the one reading this now, special or privileged? Why does it feel like you are this particular copy, and not one of the others? This is related to a deep problem in philosophy of mind called the indexical problem. The word I is indexical, meaning it refers to whoever is using it. When you say I, you refer to yourself, and when someone else says I, they refer to themselves. But if there are infinite copies of you all saying I, all referring to themselves, what picks out which one you actually are? Some philosophers suggest there is no fact of the matter about which copy you are. All the copies exist, all say I, all experience themselves as the unique individual. Your feeling of being this particular copy is not a fact about which copy you objectively are, but simply the perspective you happen to occupy. This is sometimes called the perspectival or subjective theory of personal identity. It suggests that being you is not an objective feature of the universe, but a subjective feature of experience, the fact that experience always happens from some particular point of view. Others take a more radical approach and argue that the existence of infinite copies shows that personal identity is an illusion, or at best a useful fiction. What we call the self is not a metaphysical entity, but a narrative we construct to make sense of our experiences. The boundaries of the self are vague and conventional, not sharp and objective. In an infinite universe, these boundaries become even more problematic. Where does one self end and another begin when infinite copies exist, all claiming to be the same person? These are deep and unsettling questions, and an infinite universe forces us to confront them. But perhaps there is a way to find peace with this paradox rather than anxiety. If there are infinite versions of you, each living their own life, each experiencing themselves as real and unique, perhaps this is not a problem, but simply the nature of reality. Perhaps identity and uniqueness were always more fluid and contextual than we thought, and the infinite universe simply makes this explicit. Let us consider another paradox of an infinite universe, one that touches on the nature of probability and expectation. If the universe is infinite and everything that can happen does happen, then every possible outcome occurs somewhere. This seems to make probability meaningless. If I flip a coin, there are universes where it lands heads and universes where it lands tails. Both outcomes are realized. So what does it mean to say the probability is 50% for each outcome? One answer is that probability is about anticipation, not about which outcome occurs. All outcomes occur in an infinite universe, but I do not know which branch I will experience. Probability measures my uncertainty about which outcome I will observe, given my current state of knowledge. Even though both outcomes happen, I will only see one of them, and probability tells me how to weight my expectations across the possible outcomes I might observe. But this answer leads to further puzzles. If all outcomes occur, why should I care about probability? If I make a decision with a small probability of disaster, the disaster will definitely occur in some branches of the infinite universe. Why does it matter that it occurs in only a small fraction of branches? Should I not weight all branches equally since they all exist? The resolution involves recognizing that probability is about frequency or measure, not just existence. In an infinite universe, we can talk about what fraction of branches have a certain property. If I flip a fair coin, half of the branches have heads, half have tails. This fraction is meaningful even in an infinite universe, because we can compare the measure of heads branches to the measure of tails branches. When I make a decision, I am affecting not just which outcomes exist. They all exist already, but the measure of outcomes with various properties. Good decisions increase the measure of positive outcomes. Bad decisions increase the measure of negative outcomes. This way of thinking requires a shift in perspective. In a finite universe, we think of probability as predicting which unique outcome will occur. In an infinite universe, we must think of probability as describing the distribution of outcomes across infinite branches. Both frameworks give the same practical advice for decision-making, but the conceptual understanding is different. This is another way in which an infinite universe changes our understanding of fundamental concepts like probability, causation, and choice. Now consider the paradox of abundance in an infinite universe. If space is infinite, then not only does everything that can happen, but everything that can exist exists. There is no scarcity in an infinite universe, no fundamental limitation on what can be. Every possible world, every possible civilization, every possible work of art, every possible moment of beauty or joy or love, all exists somewhere in the infinite expanse. This is sometimes called the plenitude principle, the idea that possibility entails actuality in an infinite universe. This principle has strange implications. It means that every story you can imagine is real somewhere. Every fictional world you can conceive is not fiction, but an actual place in the infinite universe, where the conditions happen to match your imagination. Every scenario, no matter how improbable, is real somewhere, because infinity ensures that all possibilities are realized. The universe contains every conceivable form of life, every possible variation on intelligence and consciousness, every possible society and culture. On one level, this is deeply beautiful. It means the universe is vastly richer than we ever imagined, that existence is not limited to what happens to occur in our observable patch of space, but extends to encompass every possibility. The universe is not just large but infinitely creative, realizing every potential in its infinite expanse. This abundance can be awe-inspiring, a reminder that reality is far stranger and more wonderful than our limited experience suggests. But on another level, this abundance can feel overwhelming or even nihilistic. If everything exists, does anything matter? If every possible outcome is realized somewhere, what significance does it have that a particular outcome occurs here? If every possible version of you exists, living every possible life, why does it matter what you do in this particular life? The paradox of abundance threatens to drain particular events and choices of meaning by placing them in the context of infinite alternatives. Yet this conclusion may be too hasty. Just because everything exists somewhere does not mean that everything is equally close or equally relevant to you. The infinite copies of you exist, but they are unimaginably far away beyond your cosmic horizon, causally disconnected from you. They cannot affect you, and you cannot affect them. For all practical purposes, they might as well not exist as far as your life is concerned. What matters is not what happens in the infinite universe as a whole, but what happens in your causal vicinity, the region of space and time you can actually influence and be influenced by. This suggests that meaning and significance are local, not global. Your actions matter not because they affect the entire infinite universe, but because they affect your local region, the people around you, the world you inhabit. The fact that there are infinite other worlds does not diminish the reality or importance of this one. This world, these people, this moment, all are real and meaningful regardless of what exists elsewhere in infinity. The infinite universe does not make your choices meaningless, but contextualizes them, reminding you that there are scales beyond the human, but also that your life is lived at the human scale, where meaning is found not in cosmic totality, but in particular relationships and experiences. Let us explore another dimension of the infinite universe paradox, the question of whether infinity can be physically real or is merely a mathematical abstraction. Mathematicians work with infinity all the time, treating it as a well-defined concept with precise properties. But mathematics deals with abstract structures, not physical reality. Can something physical, like the universe, actually be infinite? Or is infinity always an idealization, something approached but never reached? This question has troubled philosophers and physicists for centuries. Some argue that physical infinity is impossible because it leads to paradoxes. The classic example is Hilbert's hotel, a thought experiment imagined by the mathematician David Hilbert. Imagine a hotel with infinitely many rooms, all occupied. A new guest arrives. Can the hotel accommodate them? Yes, by moving the guest in room 1 to room 2, the guest in room 2 to room 3, and so on, leaving room 1 empty for the new arrival. But this seems paradoxical. How can a fully occupied hotel have room for more guests? The resolution is that infinity does not behave like finite quantities. In an infinite universe, you can always fit more in because there is always more space, always more room, always more capacity. This is counterintuitive, but not contradictory. It simply shows that our intuitions developed for dealing with finite quantities do not apply to infinity. Infinity has its own logic, its own rules, which are strange but consistent. Other paradoxes arise from the notion of traversing infinity. If space is infinite, can you ever travel an infinite distance? It seems not, because no matter how far you travel, you have only covered a finite distance, leaving an infinite distance still to go. But this is not really a paradox. It simply shows that you cannot traverse all of infinity, which is obvious. You can travel as far as you like, but there will always be more space beyond. This does not mean infinity cannot exist, only that it cannot be exhausted or fully explored by finite beings. Some physicists and philosophers argue that physical infinity is unproblematic and that the universe may well be infinite in extent. Others argue that infinity is a mathematical idealization and that the universe, while perhaps very large, must ultimately be finite. This debate is partly empirical. We may find evidence that constrains the size of the universe, but it is also partly conceptual, hinging on what we mean by physical existence and whether we are willing to accept infinity as a feature of reality. One argument in favor of physical infinity is that it simplifies our theories. If the universe is finite, we must explain why it has the particular finite size it does, what determines its boundaries, why space stops where it does. These questions are difficult and may require additional assumptions or mechanisms. If the universe is infinite, these questions do not arise. Space does not stop, it simply continues, and no special explanation is needed. Infinity, in this view, is more parsimonious than finitude, requiring fewer assumptions rather than more. On the other hand, infinity introduces its own conceptual difficulties, as we have seen. It leads to the existence of infinite copies, to paradoxes of identity and probability, to the challenge of making sense of choice and meaning in a context of infinite alternatives. Whether these difficulties are more or less problematic than the difficulties of a finite universe is a matter of philosophical judgment. The paradox here is that both infinity and finitude seem to lead to deep puzzles. If the universe is finite, we must explain its boundaries. If the universe is infinite, we must grapple with the strange implications of infinity. There may be no fully satisfying resolution, no way to avoid all paradoxes. Perhaps the universe simply is paradoxical in some respects, and we must learn to live with that strangeness rather than expecting a tidy, intuitive picture. Now let us turn to a more concrete paradox, one that connects the infinity of space to the infinity of time. If the universe is infinite in space, and if matter and energy are distributed throughout it, then there is an infinite amount of stuff out there. But the observable universe contains only a finite amount of matter and energy. This is not because space ends at the cosmic horizon, but because light from beyond the horizon has not had time to reach us. The observable universe is a finite sphere carved out of an infinite whole. As time passes, more distant regions come into view. The cosmic horizon grows and the observable universe expands. But if the universe is infinite, the observable region will always be finite, always surrounded by an infinite expanse that remains unobservable. We will never see the whole, never observe more than a finite fraction of infinity, which is to say, an infinitesimal fraction, essentially zero. No matter how long we observe, the vast majority of the universe will remain forever hidden. This is a humbling thought. It means that our knowledge, no matter how much it grows, will always be infinitesimal compared to what exists. If the universe is infinite, we can never know more than an infinitesimally small part of it. The limit to our knowledge is not just practical, but principled. There is a horizon beyond which information cannot reach us, not because we lack the technology to observe it, but because the structure of space-time itself prevents it. The speed of light is finite, the age of the universe is finite, and these two facts combine to create a boundary to the observable. This boundary, the cosmic horizon, is not a physical barrier but an informational one. It does not mark the edge of the universe, but the edge of what we can know about the universe. Beyond it, galaxies exist, stars shine, planets orbit, perhaps civilizations rise and fall, all utterly beyond our ken. These distant regions are real, just as real as the parts we can see, but they are epistemically inaccessible, forever unknowable to us. This creates a tension between what is real and what is knowable. Science generally assumes that reality is what we can observe, or at least what we can infer from observations. But in an infinite universe, most of reality is unobservable. Does this mean we should not consider it real? Or does it mean we must expand our notion of reality beyond the empirically accessible? Different philosophers and scientists answer this question differently. Empiricists argue that we should restrict our ontology, our catalog of what exists, to what we can observe or test. By this criterion, the unobservable regions beyond the cosmic horizon should not be considered part of our scientific understanding. They are metaphysical speculation, not physics. Realists, on the other hand, argue that reality extends beyond the observable, that just because we cannot see something does not mean it does not exist. If the laws of physics and the structure of space suggest that the universe extends beyond our horizon, then we should accept that these regions exist even though we cannot observe them. This debate is not easily resolved, and an infinite universe makes it especially acute. The stakes are high because the majority of the universe, in fact an infinite amount of the universe, lies beyond our horizon. If we restrict our ontology to the observable, we are ignoring most of reality. But if we accept the unobservable, we are making claims that can never be directly verified. The paradox is that both positions seem unsatisfying. Perhaps the resolution is to recognize that science deals with models and theories, not directly with reality itself. Our cosmological models suggest an infinite universe extending beyond the cosmic horizon. These models are supported by observations within the horizon and are consistent with our best physical theories. We can accept these models as our best current understanding, while remaining open to revision if new evidence or new theories suggest otherwise. The unobservable regions are part of our model of reality, even if they are not directly observable. This is a pragmatic approach, neither purely empiricist nor purely realist, but something in between. Let us now consider the paradox of initial conditions in an infinite universe. The universe, according to modern cosmology, began in a hot, dense state known as the Big Bang. From this initial state, the universe expanded, cooled, and evolved into the complex structure we observe today. But if the universe is infinite, how do we make sense of initial conditions? An infinite universe requires infinitely many initial conditions, specifying the state of every point in infinite space. How can such an infinity of initial conditions be specified or explained? One response is that the initial conditions were nearly uniform. In the very early universe, space was almost the same everywhere, with only tiny fluctuations in density and temperature. These fluctuations, which we observe imprinted in the cosmic microwave background, were the seeds of all later structure. Because the initial state was so uniform, we do not need to specify infinitely many independent initial conditions. We can describe the state of the early universe with a simple rule: nearly uniform with small random fluctuations of a particular type. This uniformity is itself puzzling and requires explanation, which is where the theory of cosmic inflation comes in, but it makes the infinite initial state conceptually manageable. Inflation suggests that the observable universe, and indeed a much larger region, was inflated from a tiny initial patch, much smaller than an atom. This tiny patch was uniform because it was so small that quantum fluctuations quickly smoothed out any variations. When inflation stretched this patch to cosmic scales, it carried the uniformity with it. If this is correct, then the uniformity of the initial conditions is explained by the dynamics of inflation, not imposed as a mysterious feature of the universe, but inflation itself requires initial conditions. The inflattened field which drove inflation had to be in the right state for inflation to occur. How likely or natural were these initial conditions? This is a matter of ongoing debate. Some argue that the conditions for inflation are generic and likely to arise in a broad range of scenarios. Others argue that they are fine-tuned and require explanation. If the universe is infinite and inflation occurred throughout infinite space, then perhaps the conditions for inflation were satisfied in some regions and not others, and we find ourselves in a region where inflation happened, because only such regions can produce observers. This brings us to anthropic reasoning, the idea that we should not be surprised to find ourselves in a universe compatible with our existence, because we could not exist anywhere else. In an infinite universe, if different regions have different properties, we will necessarily find ourselves in a region suitable for life. This does not explain why the universe has the properties it does, but it explains why we observe those properties. The infinite universe provides a context in which anthropic reasoning becomes powerful, because it ensures that all possible regions exist, including the rare ones compatible with life. However, anthropic reasoning is controversial. Critics argue that it is not truly explanatory. That saying we are here because we could not be anywhere else does not tell us why the universe allows observers at all. It also raises problems of probability. If there are infinitely many regions where observers could exist, how do we calculate the probability of observing various properties? Should we count regions by volume, by the number of observers, by some other measure? These questions do not have obvious answers, and different measures can give different results, leading to what is called the measure problem in cosmology. The measure problem is a deep issue in the physics of infinite universes. If space is infinite and different regions have different properties, how do we make statistical predictions? In a finite universe, we can count how many regions have a given property and divide by the total number of regions to get a probability. But in an infinite universe, both the numerator and denominator are infinite and the ratio is undefined. We need some way to compare infinities, some measure that assigns relative weights to different regions. But there is no unique or obvious way to do this, and different measures can give wildly different predictions. This is not just a technical issue, but a conceptual one. It suggests that probability, as ordinarily understood, may not apply straightforwardly in an infinite universe. We may need a new framework for thinking about prediction and expectation when dealing with infinity. Some physicists are developing such frameworks, exploring different measure proposals and their consequences, but no consensus has emerged. The measure problem remains an open challenge for cosmology, a paradox arising from the conjunction of infinity and probability. Another paradox concerns the arrow of time in an infinite universe. Time, as we experience it, has a direction. The past is different from the future. Eggs break but do not spontaneously reassemble. Memories are of the past, not the future. Entropy increases, meaning that systems become more disordered over time. This arrow of time is one of the most fundamental features of our experience, yet it is not clearly explained by the fundamental laws of physics, which are mostly time-symmetric. The usual explanation for the arrow of time is that the universe began in a low-entropy state, and entropy has been increasing ever since. The Big Bang was a state of very high order, despite being very hot and dense, because all the matter and energy were distributed very smoothly with only tiny fluctuations. As the universe expanded and cooled, gravity amplified these fluctuations, creating structure, stars, galaxies, planets. This process increases entropy because energy becomes more spread out, more degraded, less available to do useful work. The arrow of time points from the low entropy beginning toward the high entropy future. But if the universe is infinite, this explanation becomes puzzling. Why was the initial state low entropy throughout all of infinite space? Why was the uniformity not just local but global, extending across infinity? In a finite universe, we can perhaps accept the low entropy initial state as a boundary condition, something we impose without further explanation. But in an infinite universe, a low entropy state requires infinitely many regions to be coordinated, to all have low entropy simultaneously. This seems to require a very special initial condition, which itself demands explanation. One possibility is that the low entropy state was established by inflation. Inflation smoothed out any pre-existing entropy gradients, creating a uniform low entropy state from which the post-inflationary universe evolved. But inflation itself requires an explanation for its initial conditions, and we are back to asking why those conditions obtained throughout infinite space. The puzzle is not eliminated but pushed back to an earlier stage. Another possibility is that the low entropy beginning is not a global feature but a local one. Perhaps the universe as a whole is in a high entropy equilibrium state, but there are rare statistical fluctuations that create low entropy regions. We find ourselves in one such region because only low entropy regions can support observers. In the vast infinity of a high entropy universe, there will be occasional low entropy fluctuations, and we necessarily inhabit one of them. This is the Boltzmann brain problem, named after the physicist Ludwig Boltzmann, who first considered such scenarios. The Boltzmann brain problem is deeply troubling. If we are just statistical fluctuations in a high entropy equilibrium universe, then it is far more probable that we are minimal fluctuations rather than extensive ones. It is more likely that just a single brain with false memories of a past and an external world fluctuated into existence rather than an entire universe with a genuine history and countless observers. But if we are Boltzmann brains, then all our memories are false, all our observations are illusions, and all our reasoning is untrustworthy. This is a radical skepticism that undermines the very possibility of knowledge. Most physicists and philosophers find this conclusion unacceptable and take it as evidence that the equilibrium fluctuation picture is wrong. We are not Boltzmann brains, and the arrow of time is not due to a rare fluctuation in an infinite equilibrium state. Instead, the universe really did begin in a low entropy state, and that state requires explanation, perhaps through a more fundamental theory that we do not yet have. The paradox remains: the arrow of time, which seems so fundamental to our experience, is deeply puzzling in the context of an infinite universe, and no fully satisfactory explanation has yet been found. Let us now turn to a more existential dimension of the infinite universe paradox, the question of meaning and purpose in a context of infinite alternatives. We have already touched on this, but it deserves deeper exploration. If every possible outcome occurs somewhere in the infinite universe, if every possible life is lived, every possible choice is made, every possible story unfolds, does this not drain particular choices and events of significance? If all versions exist, why does it matter which version you are or what happens in your particular branch? This concern is sometimes called the problem of cosmic insignificance. It is the worry that the vastness and multiplicity of the universe make individual lives and actions trivial. If you are one among infinite copies, if your life is one among infinite variations, how can it matter what you do? Any impact you have is infinitesimal. Any uniqueness you possess is illusory. The infinite universe seems to trivialize existence by placing it in overwhelming context of endless alternatives. One response to this worry is to reject the assumption that significance requires uniqueness or cosmic importance. Why should your life matter only if you are unique in the universe? Why should your actions matter only if they affect the entire cosmos? Significance and meaning are not about cosmic scale, but about local relationships and values. Your life matters to you and to the people you interact with, regardless of what happens elsewhere in infinity. The existence of infinite copies does not change the fact that you have particular experiences, particular relationships, particular opportunities to create meaning and value in your local context. Another response is to embrace the multiplicity rather than fearing it. If every version of you exists, then the question is not whether to exist, but how to exist. Not whether your choices matter, but what kind of life you choose to live. The infinite universe ensures that all possibilities are explored, but you are responsible for which possibility you actualize in your branch. Your choices shape your experience and the experiences of those around you, and this shaping is meaningful, even though other branches explore other options. Meaning is not about being the only one or affecting everything, but about engaging authentically with your own life and relationships. A third response is to recognize that the infinite universe, while real, is not experientially accessible. You experience only your own branch, your own life, your own choices. The copies exist, but they are as distant and irrelevant to your daily experience as the distant galaxies. Just as the existence of billions of galaxies does not make your own planet less real or important to you, the existence of infinite copies does not make your own life less meaningful. Meaning is found in experience, not in cosmic uniqueness, and your experience is singular, even if your configuration is not. These responses suggest that the problem of cosmic insignificance is based on a mistaken assumption about the source of meaning. Meaning does not come from being unique in the universe or from affecting the entire cosmos. It comes from engagement, from relationships, from values, from the experience of being alive and conscious. These sources of meaning are not threatened by the infinite universe. They are local, personal, immediate, grounded in the structure of experience rather than in cosmic facts. Yet the worry persists for some people. If all choices are made, if all paths are taken, it can feel as though nothing is at stake, as though decisions do not really matter, because every alternative is realized somewhere. This feeling might not be rationally justified, but it is psychologically real. How can we find a way to live with the infinite universe that does not drain life of felt significance? Perhaps the key is to shift from thinking about what exists to thinking about what you experience and create. The infinite universe exists independently of you, containing all possibilities. But your life is not about the infinite universe as a whole. It is about the particular path you walk, the particular experiences you have, the particular relationships you build. You cannot experience all branches, only this one. You cannot live all lives, only yours. And within your life, your choices shape your trajectory, determine what you experience, affect the people you encounter. This shaping is real and meaningful, regardless of what happens in other branches. Furthermore, even if all outcomes exist, there is value in the process, in the journey, in the way you navigate your choices. The destination may be reached in every branch, but how you get there, the path you take, the manner in which you engage with life, these have intrinsic value. Living with integrity, with compassion, with curiosity, with courage, these qualities matter, not because they produce unique outcomes, but because they constitute a good way of being. The infinite universe does not change this. It simply reminds us that meaning is about how we live, not about whether we are cosmically unique. Let us consider one final paradox, perhaps the most profound, the question of why there is an infinite universe at all. Why does infinity exist? Why is there something rather than nothing? And why is that something infinite rather than finite? These are age-old metaphysical questions, but the possibility of an infinite universe gives them new urgency. If the universe is finite, we can perhaps accept it as a brute fact, something that simply is without further explanation. A finite object can be thought of as a particular thing that happens to exist. But infinity is not a particular thing, but a limitless expanse, and it seems to demand explanation in a different way. Why would existence be limitless? What could cause or account for infinity? One answer is that infinity is the default, that it requires less explanation than finitude. Finitude implies boundaries, and boundaries require explanation. What stops space at some particular point? What determines the size of a finite universe? These questions are difficult. Infinity, by contrast, has no boundaries, no limits, no particular size to explain. In this view, infinity is simpler than finitude, more natural, less in need of explanation. Another answer invokes necessity. Perhaps the universe must be infinite, not as a contingent fact, but as a necessary truth, just as mathematical infinity is a necessary feature of the number line, not something that could have been otherwise. Perhaps physical infinity is a necessary feature of reality. This would mean that nothingness is impossible, that something must exist, and that what exists must be infinite. This is a bold claim, and it is not clear how to justify it, but some philosophers and physicists have suggested versions of this idea. A third answer is that infinity arises from the nature of the laws of physics. If the fundamental laws are what they are, and if those laws imply an infinite universe, then infinity is explained by the laws, and the laws themselves are the basic unexplained explanatory framework. This pushes the question back: why these laws rather than others? But it does provide an explanation of infinity within the framework of physical theory. Yet another answer is anthropic. The universe is infinite, because only an infinite universe can produce observers like us. A finite universe might not have the right conditions anywhere, or might have them only rarely and unreliably. An infinite universe guarantees that all possibilities are explored, including the rare conditions needed for life and consciousness. We find ourselves in an infinite universe because only an infinite universe can reliably produce beings to observe it. This is a form of anthropic reasoning applied to the question of infinity itself. None of these answers is entirely satisfying, and the question of why there is an infinite universe remains one of the deepest mysteries. It touches on the boundary between physics and metaphysics, between what science can explain and what requires philosophical or even theological consideration. The infinite universe is a fact, if it is a fact that demands explanation, yet it may be that no explanation is possible, that existence and infinity are simply given, the ultimate brute facts that ground all other facts. This is a humbling conclusion, but perhaps an appropriate one. The infinite universe, if it exists, is the ultimate mystery, the final frontier of understanding. It challenges our concepts, strains our intuitions, raises paradoxes we struggle to resolve. Yet it is also awe-inspiring, a reminder of the vastness and strangeness of reality, a context that makes our lives both infinitesimally small and profoundly meaningful. As we bring this contemplation to a close, let us rest in the paradox rather than trying to resolve it. The infinite universe is both real and unreal, both graspable and incomprehensible, both trivializing and ennobling. It exists or may exist beyond our direct experience, yet it shapes the framework in which we understand ourselves and our place in the cosmos. It is a concept that pushes us to the limits of thought, and in that pushing, we learn something about the nature of reality and the nature of ourselves. You are here, in this moment, in this place, in this particular branch of reality. Whether there are infinite other versions of you does not change the reality of your experience. You are conscious, alive, capable of wonder and thought. You can contemplate infinity even though you are finite, can think about the paradoxes of the infinite universe even though your own life is limited and local. This capacity for thought, this ability to transcend your immediate circumstances through imagination and reason, is itself a kind of infinity, a boundlessness of mind that mirrors the boundlessness of space. The infinite universe, if it exists, is not something separate from you, but something you are part of, something that includes you in its vast expanse. You are a point in infinity, a particular manifestation of the cosmos, a fleeting pattern in an endless sea of possibilities. But you are also the place where infinity becomes conscious of itself, where the universe reflects on its own existence. In this sense, you are not insignificant, but essential, not trivial, but profound, not lost in infinity, but a window through which infinity looks at itself. So rest now, let the paradoxes settle into your mind like stones in still water, creating ripples that fade into calm. The infinite universe is strange, but you are part of its strangeness. It is beautiful, and you are part of its beauty. It is mysterious, and your consciousness is part of its mystery. You are small, yes, but you are also infinity, aware of itself, and that is enough. That is more than enough. That is everything. But let us linger here a while longer, for there are still more layers to these paradoxes, more dimensions of infinity to explore before we release ourselves into sleep. The infinite universe is not just a single idea, but a constellation of interconnected concepts, each revealing different aspects of what it means for reality to be boundless. Consider the paradox of the infinite library. Jorge Luis Borges imagined a library containing all possible books, every combination of letters that could form a text of a certain length. Such a library would be vast but finite, because there are only finitely many ways to arrange a finite number of letters. But now imagine expanding this concept to an infinite universe. If space is infinite and contains matter, then somewhere in that infinite expanse there exists not just every possible book, but every possible library, every possible collection of information, every possible arrangement of data. The infinite universe is the ultimate library, containing not just descriptions of all possibilities, but the actual realization of all possibilities. This means that somewhere in the infinite universe there exists a planet where the exact text of every book you have ever read is carved into mountainsides. Somewhere there exists a civilization that has independently developed the same literature, the same science, the same art as human civilization, down to every detail. Somewhere there exists a version of Earth where history played out differently at every possible divergence point. The infinite universe does not just contain possibilities. It contains actual physical instantiations of every possible scenario. This realization can be dizzying. It suggests that imagination and reality are not as distinct as we usually think. Every consistent imaginary world you can conceive corresponds to an actual place somewhere in the infinite universe. Fiction becomes a kind of telescope, allowing us to peer not just into possibility, but into distant actuality. When you read a novel or watch a film, you are not just entertaining yourself with made-up stories, but exploring regions of the infinite universe where those stories are real. Of course, the distance to these regions is so vast as to be meaningless. They are beyond the cosmic horizon, causally disconnected from us, as inaccessible as if they did not exist. But they do exist if the universe is truly infinite and matter is distributed throughout it. This existence in principle but inaccessibility in practice is itself paradoxical. What does it mean for something to exist if we can never interact with it, never observe it, never be affected by it in any way? Is existence without causal connection still meaningful? Philosophers have long debated the nature of existence and reality. Some argue that to exist is simply to be part of the causal network of the universe, to be able to interact with other existing things. By this criterion, regions beyond the cosmic horizon do not exist for us because they cannot causally interact with our region. They are outside our universe in any meaningful sense. Others argue that existence is more fundamental than causal interaction, that something can exist even if it is causally isolated. By this criterion, the regions beyond the horizon do exist. They are real parts of the infinite universe, even though we can never know them. Perhaps both perspectives capture something true. From a practical, epistemic standpoint, the inaccessible regions might as well not exist. They make no difference to our observations or lives. But from an ontological, metaphysical standpoint, they are as real as anything in our observable region, existing according to the same laws of physics, made of the same kinds of matter and energy. The paradox is that existence seems to come in degrees or aspects. Full existence for things we can interact with, attenuated existence for things beyond our causal reach. This connects to another paradox, the problem of infinity and identity over time. In a finite universe, we can trace the history of particular objects and say that an object at one time is the same object at another time if there is an appropriate causal connection between them. But in an infinite universe with infinite copies, identity becomes ambiguous. If there are infinite copies of you, and they evolve in slightly different ways, which future person is you? Are all of them you? Is there a fact of the matter about which continuation you will experience? Some philosophers argue that personal identity over time is conventional or pragmatic, not metaphysically fundamental. We trace identity through time in ways that are useful and make sense given our cognitive architecture and social practices, but there is no deep fact about which future person is identical to which past person. The infinite universe makes this explicit by providing clear cases where our usual criteria for identity give ambiguous results. In a finite universe, these ambiguities rarely arise, but in an infinite universe, they are ubiquitous. This suggests a more general point. Many of our concepts and categories are adapted to finite, local contexts, and break down or become ambiguous when applied to infinite, global contexts. Identity, uniqueness, probability, causation, meaning, all of these concepts work well in our everyday finite environment, but become problematic when we try to extend them to the infinite universe as a whole. This does not mean the concepts are wrong or useless, but it means they are context-dependent, tools for navigating our local environment rather than absolute features of ultimate reality. The infinite universe thus serves as a kind of philosophical laboratory, revealing the limits and presupposition of our conceptual frameworks. It shows us that our intuitions, valuable as they are for everyday life, are not reliable guides to the structure of reality at the largest scales. We must use reason and mathematics to extend our understanding beyond intuition, but even reason and mathematics sometimes lead to results that feel paradoxical or counterintuitive. Let us explore the temporal dimension of infinity more deeply. We have focused mostly on spatial infinity, but time raises its own paradoxes. If space is infinite, what about time? Was the universe always infinite in time, or did time itself begin at some point? Modern cosmology suggests that time began with the Big Bang, that there was no before the Big Bang, because time itself came into existence then. But this is difficult to comprehend. How can time begin? What does it mean to have a first moment of time? One way to think about it is that time is not a container that existed before the universe, but a feature of the universe itself, a dimension of the space-time structure. When the universe began, space-time began, and there is no meaningful sense in which we can ask what came before, because before is a temporal concept that presupposes the existence of time. This is logically consistent, but deeply counterintuitive. We are used to thinking that everything has a cause, that every beginning must be preceded by something, but the beginning of time itself cannot have a temporal cause, because causes require time to operate. Some cosmologists speculate about what might have existed before the Big Bang, but they are really asking about different regions of a larger space-time structure, not about a temporal before. The universe might be part of a multiverse where different regions have their own Big Bangs, their own time dimensions. Our time began with our Big Bang, but there might be other time dimensions and other regions not temporally related to ours. This is mind-bending. The idea that there are multiple time dimensions not ordered relative to each other, but it is one way to make sense of the question of what came before the beginning. Alternatively, the universe might be cyclical, going through infinite cycles of expansion and contraction, big bangs followed by big crunches followed by new big bangs. In this scenario, time extends infinitely into the past and future, with no absolute beginning or end, just endless cycles. Each cycle might have different properties, different physical constants, different structures. Our universe would be one phase in an eternal cycling process, and questions about the ultimate beginning of time would not arise, because there is no beginning, just an infinite regress of cycles. But infinite regress raises its own paradoxes. If there have been infinitely many cycles before this one, then an infinite amount of time has already passed. But how can an infinite amount of time pass? Infinity is not a number that can be reached by counting or waiting. If we think of time as a sequence of moments, then infinitely many moments cannot all have occurred unless the sequence has no beginning. But a sequence with no beginning is hard to conceptualize. It means that no matter how far back we go, there is always an earlier moment, with no first moment to serve as the starting point. These paradoxes of infinite time are similar to the paradoxes of infinite space, but applied to the temporal dimension. They suggest that our usual ways of thinking about time, derived from our experience of finite temporal intervals, may not apply to infinite time. Just as spatial infinity requires us to revise our intuitions about space, temporal infinity would require us to revise our intuitions about time, causation, and change. Current evidence suggests that our universe is finite in time, having begun at a definite point in the past. But we cannot rule out the possibility that time extends beyond our universe, either into a cyclic structure or into a larger multiverse with its own temporal dimensions. The question of temporal infinity remains open, a frontier of cosmological speculation and philosophical reflection. Now consider the paradox of information in an infinite universe. Information theory tells us that information is physical, that it requires matter or energy to instantiate. If the universe is infinite and contains infinite matter and energy, then it contains infinite information. But what does it mean to have infinite information? Can infinite information be processed, stored, or transmitted? These questions lead to deep puzzles. One puzzle is the holographic principle, which suggests that the information content of a region of space is limited not by its volume, but by the area of its boundary. This principle emerges from black hole thermodynamics and has been generalized to cosmology. If the holographic principle is correct, then the information content of the observable universe is finite, even though the universe itself might be infinite. The information we can access is limited by our cosmic horizon, which has a finite area and therefore can encode only a finite amount of information. But what about the information beyond the horizon? If the universe is infinite, there is infinite information out there, but we cannot access it. This raises the question of whether inaccessible information is still information in any meaningful sense. Information is usually understood in terms of its potential to affect observers, to be communicated and processed. If information is permanently inaccessible, beyond any possible causal contact, does it still count as information? This connects to the earlier question about the existence of unobservable regions. Just as we debated whether causally disconnected regions exist in a meaningful sense, we can debate whether inaccessible information exists in a meaningful sense. Perhaps information, like existence, comes in degrees: fully real information that we can access and process, and merely abstract or potential information that exists mathematically but cannot be actualized for us. Another information paradox arises from quantum mechanics. Quantum information theory shows that information cannot be destroyed, even when it falls into a black hole. This is the information conservation principle, and it is believed to be a fundamental law of physics. But if the universe is infinite, with infinitely many black holes forming and evaporating, what happens to all the information that passes through them? Is information conserved globally in an infinite universe, or only locally within finite regions? The answer may depend on how we define conservation in an infinite context. In a finite universe, we can add up all the information and show that the total remains constant. In an infinite universe, the total information is already infinite, and adding or subtracting finite amounts does not change the infinity. Conservation might have to be understood locally as applying to finite regions rather than globally. This is another example of how infinity changes the meaning of familiar concepts. The paradoxes of information in an infinite universe also touch on the question of whether the universe is a simulation, a hypothesis that has garnered attention in recent years. If the universe were a computer simulation, It would require infinite computational resources to simulate an infinite universe in full detail. This seems to rule out the simulation hypothesis if the universe is infinite, unless the simulation itself is infinitely large, or unless only a finite region is simulated in detail, with the rest existing only schematically. These are wild speculations, but they show how the concept of infinity intersects with contemporary debates about the nature of reality. Let us turn now to the aesthetic and emotional dimensions of the infinite universe. How should we feel about living in an infinite cosmos? Is it terrifying, comforting, inspiring, depressing? Different people have different reactions, and these reactions reveal deep aspects of human psychology and values. For some, infinity is terrifying. It represents a loss of boundaries, a dissolution of the familiar and comprehensible. The infinite universe is too large, too strange, too overwhelming. It makes human concerns seem trivial, human existence seem insignificant. This terror of infinity is not irrational, but reflects a genuine psychological need for a sense of scale that allows us to feel oriented and grounded. In an infinite universe, these limits dissolve, and we are left floating in a boundless expanse that offers no fixed points, no ultimate frame of reference. For others, infinity is comforting. It suggests that there is always more, that existence is not limited or constrained, that possibilities are endless. The infinite universe guarantees that anything that can happen does happen, that no possibility is left unrealized. This can be reassuring, a promise that the cosmos is maximally rich and generous, that existence is abundant rather than scarce. The infinite universe is a source of hope, suggesting that there is always something more to discover, always new wonders beyond the horizon. For still others, infinity is inspiring. It challenges us to expand our minds, to think beyond the limits of everyday experience, to grapple with concepts that strain our cognitive capacities. The infinite universe is a call to intellectual and imaginative growth, an invitation to transcend our limitations and engage with reality at its most fundamental and mysterious levels. This inspiration can motivate scientific inquiry, philosophical reflection, artistic creation, all the ways humans strive to understand and express their relationship to the cosmos. And for some, infinity is simply neutral, a fact about the universe that does not carry strong emotional valence. These people might acknowledge the strangeness and paradoxes of infinity, but do not find them particularly troubling or inspiring. They accept infinity as part of the structure of reality and go about their lives without dwelling on it. This pragmatic attitude has its own wisdom, recognizing that while infinity is fascinating, it does not directly impact our daily existence, and we can live meaningful lives without constantly contemplating cosmic scales. These varied reactions to infinity reflect different philosophical temperaments and different answers to the question of what matters in life. If you find meaning in boundaries and limits, infinity may be disturbing. If you find meaning in boundlessness and possibility, infinity may be comforting. If you find meaning in intellectual challenge, infinity may be inspiring. And if you find meaning in immediate relationships and experiences, infinity may be largely irrelevant to your concerns. There is no single correct emotional response to the infinite universe, just as there is no single correct philosophy of life. But regardless of our emotional response, the possibility of an infinite universe invites us to reflect on our place in the cosmos. It raises questions about what it means to be human in a universe without boundaries, about how we should understand ourselves and our values in a context of infinite alternatives. These are not just intellectual questions, but existential ones touching on how we live and what we care about. One way to approach these questions is through the concept of scale. Humans exist at a particular scale, neither the smallest nor the largest. We are larger than atoms, but smaller than planets, longer-lived than mayflies, but shorter-lived than mountains. Our concerns and values are adapted to this intermediate scale. We care about things that happen on timescales of seconds to decades, at spatial scales of meters to kilometers. These are the scales of human life, and they define the context in which we find meaning. The infinite universe exists at scales vastly beyond the human. It stretches across distances we can never traverse, encompasses times we can never witness, contains variations we can never experience. These cosmic scales are not our scales, and we should not expect our values and meanings to apply to them directly. The infinite universe is not indifferent to us, it is simply operating at a different scale where human categories of meaning and value do not naturally apply. This suggests that the appropriate response to the infinite universe is not to try to find meaning at the cosmic scale, but to recognize that meaning is scale-dependent. At the human scale, our lives, relationships, and choices matter deeply. At the cosmic scale, they are insignificant. Both statements are true, and they do not contradict each other because they apply at different scales. The challenge is to hold both perspectives simultaneously, to appreciate the vastness of the cosmos without letting it diminish the reality and importance of human-scale concerns. This multi-scale perspective is not easy to maintain. We naturally toggle between feeling cosmically insignificant and feeling that our lives matter greatly. The trick is to integrate these feelings to see that we are both insignificant and significant, both tiny and important, depending on the scale at which we view ourselves. The infinite universe provides the context of insignificance, but our immediate lives provide the context of significance, and we live in both contexts at once. Let us consider one more paradox before we close, the paradox of the observer in an infinite universe. If the universe is infinite, and if consciousness is a physical phenomenon arising from certain configurations of matter, then there are infinitely many conscious observers scattered throughout the infinite expanse. Each observer has their own perspective, their own sense of being the center of their experience. But from a cosmic standpoint, there is no privileged observer, no special perspective that is more real or important than any other. This raises the question, why are you this particular observer rather than one of the infinitely many others? This is the indexical problem again, but now applied not just to personal identity over time, but to the question of which observer you are at all. If consciousness arises wherever the physical conditions are right, and those conditions are met infinitely many times in an infinite universe, then consciousness is not a single phenomenon, but a multiply instantiated one. There are infinitely many consciousnesses, each thinking of itself as I, each experiencing itself as the unique center of awareness. From an objective standpoint, there is nothing that picks out which consciousness is yours. They are all equally real, all equally conscious, all equally thinking of themselves as I. Your sense of being this particular consciousness, experiencing this particular life, is not an objective fact about the universe, but a subjective fact about your perspective. You are this consciousness because this is the perspective you happen to occupy, not because there is some objective feature that makes you this one rather than another. This can feel unsettling. It suggests that your identity, your sense of being a unique individual, is not grounded in objective reality, but is a feature of perspective, of the fact that experience always happens from some particular point of view. You are you not because you are objectively special, but because you are the perspective from which you view the world. All the other observers are equally you, in the sense that they are equally conscious perspectives, but you experience only this one, because perspective is necessarily singular from the inside, even if it is plural from the outside. This insight can be liberating or disconcerting, depending on how you hold it. It can be liberating because it frees you from the illusion that you need to be objectively special to matter. You matter not because you are unique in the cosmos, but because you are the center of your own experience, and that is enough. Or it can be disconcerting because it undermines the sense of being a distinct, bounded self with a clear identity separate from others. If all conscious perspectives are equally I, then the boundary between self and other becomes blurred, and personal identity becomes more fluid and less well-defined than we usually think. Perhaps the deepest paradox of the infinite universe is this: it is both utterly impersonal, indifferent to any particular observer or event, and yet the only way we know it is through personal, subjective experience. The universe does not care about us, but we care about the universe, and in caring, we bring value and meaning into existence. The infinite cosmos is cold and mathematical, but it has produced beings capable of warmth and emotion, and in those beings the cosmos becomes aware of itself, reflects on its own nature, finds beauty and meaning in its own structure. You are one such being. You are a way the infinite universe has of experiencing itself. Through your eyes, the cosmos looks at itself. Through your thoughts, the cosmos contemplates its own existence. Through your feelings, the cosmos values itself. You are not separate from the infinite universe, but a part of it, a local concentration of complexity and consciousness, a place where matter has organized itself in such a way that it can wonder about infinity. And so we return to where we began, with you lying comfortably, eyes closed, drifting toward sleep. The infinite universe stretches out beyond imagination, containing all possibilities, all variations, all alternatives. You are one point in that infinity, one perspective, one conscious observer among infinitely many. But you are also the only you that you experience, the only perspective you inhabit, the only life you live. And that makes you both infinitesimal and infinite, both insignificant and essential, both a fleeting pattern and a permanent feature of reality. The paradoxes of infinity cannot be fully resolved, only appreciated and held lightly. The infinite universe is strange, but you are part of its strangeness. It is beautiful, and you are part of its beauty. It is mysterious, and your consciousness is part of its mystery. Rest in this knowledge. Let the infinity outside mirror the infinity within, the boundlessness of space reflecting the boundlessness of mind. You are here now, part of the infinite universe, and that is enough. That is everything. Sleep now, gently, softly,